All right, so in this video, we're doing 12.5, the multiplication rule. So the multiplication rule basically just says if I want to know the probability of more than one event occurring, then I can just multiply their individual probabilities together. Um, there is a slight difference depending on if the events are independent or dependent. So the first definition here is for independent events. If I have independent events and both events come from the same sample space, the probability that both A and B occur is equal to the probability that event A occurs times the probability that event B occurs. If the events are dependent, then basically the same rule applies, but it would be the probability that A occurred times the probability that B occurs given that A has already occurred. Okay, so we're just going to go ahead and do a bunch of examples of this. So let me see. Let's go ahead to the next. All right. You toss a coin 3 times. What is the probability you'll get a tail on all 3 tosses? So first of all, we need to think about this. Would this be dependent or independent? These events would be independent because each toss will not be affected by the one before it. The probability of each toss is still 1 out of 2 each time. So on the first toss, the probability of getting a tail is 1 out of 2. And the multiplication rule says that I'm just going to multiply these probabilities together. The probability of the second toss would just be 1 out of 2. And the probability of the third toss would be 1 out of 2. So the probability of getting tails 3 times in a row would be 1 out of 2 times 1 out of 2 times 1 out of 2. So when you're multiplying fractions, remember you're going to multiply the numerators together. So 1 times 1 times 1 is 1. And in the denominator, I'm going to multiply the denominators together. So 2 times 2 is 4, and 4 times 2 is 8. So the probability of getting 3 tails is 1 out of 8. And then I want to change that to a percentage by changing it first to a decimal, which would be 0.125. And then we can change that to a percentage by multiplying it by 100. So 12.5% chance of getting 3 tails in a row. If I roll a die 2 times, what is the probability that I roll a 5 the first time and an even the second time? So again, independent events, because if I roll the first die, that's not going to affect the probability of rolling the second die. So on the first roll, if I were to roll a 5, there would be a 1 in 6 chance I could get a 5. On the second roll, if it's even, there would be a 3 out of 6 chance of it being even. So the probability would be 1 times 3 over 6 times 6. So 3 out of 36. Now on your assignment, it's going to ask you to reduce the fraction and then to change it into a percentage. So 3 out of 36 reduces to 1 out of 12. So that's the reduced fraction. Just take any common factor out of the fraction. And then go ahead and change it into a percentage. 1 divided by 12 is equal to 0.083. So the percentage would be 8.33%. Okay, let's try something else. Maybe. A jar contains 3 red marbles and 2 black marbles. So altogether there are 5 marbles in this jar. All the marbles are the same size and there are no other marbles in the jar. On the first selection, a marble is chosen at random and then replaced. Then a second marble is chosen at random. What is the probability that the marbles chosen at random will first be a black marble and then a red marble? Okay, so the important part here is that it tells us that the marble is not replaced. Okay, because the marble is not replaced, these are dependent events. Because the first probability of getting a black first is there's going to be 5 total marbles in the bag. And so let's see. Yeah, so black would be 2 out of 5. But now the next time I draw one out, there are no longer 5 marbles in there, right? So the probability of getting red is now going to be out of 4 instead of out of 5. So that's why these are dependent. There are 3 red marbles. So the probability here would be 2 out of 5 times 3 out of 4. So the first one is just the probability of drawing out a black marble. The second one is the probability of grabbing a red marble given that there's already one black marble gone. Okay. So this is equal to 6. 2 times 3 is 6, 5 times 4 is 20. To reduce that fraction, I would take the common factor 2 out of both of these. This would become 3 over 10, and then changing that to a percentage, that would be 30%. So again, on your homework, I want to see both the reduced fraction and the percentage. 5 different colored pencils are placed in a box. The pencil colors are red, yellow, blue, purple, and green. So it looks like there's just one of each type of pencil, one of each color of pencil in the box. 3 pencils are selected at random and not replaced. Again, that's the important part. Was it replaced or wasn't it after each draw? What is the probability that the first pencil selected is yellow? So on that, there's going to be 1 out of 5 chances that I get a yellow on the first draw. The second is purple. Now there's only one purple pencil in the box, but if I've already drawn out a yellow pencil, then there's only going to be 4 left. And then the probability of grabbing that third pencil that's green would be 1 out of 3. Okay, so this is going to be equal to 1 over 60. 5 times 4 is 20, 20 times 3 is 60. Change it to a percentage. Is going to be 1.67%. Okay, so it comes out to 0.0166 repeating, so that would be 1.67%. All right, let's look at another one. Your drawer contains 5 red socks and 3 green socks. It's too dark to see which are which. What is the probability that the first 2 you pick are both green socks with replacement? So that means I grab some socks, I see that they're green, I replace them, so I throw them back in, and then I grab some socks again. So the first probability, since there are 3 green socks out of 8 total socks, would be 3 out of 8. On the second draw, since I replaced them, there would still be 8, and if I wanted green again, it would still be 3 out of 8. So 9 out of 64. So let's go ahead and reduce our fraction. And 9 out, let's see. Actually, they won't reduce. So that is the reduced fraction. And then we're going to go ahead and change that to a decimal. Sorry, 1 second. 9 divided by. So that gives me 0.1406, which means my percentage would be 14.06%. What is the probability that you choose 2 green and then a red without replacement? So on the first draw, I grabbed a green, or what's the probability of getting green would be 3 out of 8. But I take that pair of green socks and I set them aside. So they don't go back in. So getting a green again, now there's only 2 green left in the drawer, and there's only 7 pairs or 7 socks in the drawer. So 3 out of 8 times 2 out of 7 for the second draw. The third draw would be red. There are still 5 red socks in the drawer, but there are only 6 pairs. So that would be 3 8s times 2 7s times 5 6. Go ahead and multiply the tops together. So that would be 30. And then 8 times 7 times 6 is equal to 336. Looks like I can reduce each of these by at least 3, so that would give me 10 over 112. Looks like I can reduce both of those by 2, so that'd be 5 over 66, 56. And then, so 5 over 56 is my reduced fraction. Change that to a decimal, and I would get 0.089. I'm going to round off to 3. And then that would be 8.93%. Okay, so we got to be paying attention to whether it's with replacement or without replacement on this multiplication rule. If we have a standard deck of 52 cards, what is the probability you will draw 2 aces in a row without replacement? Meaning I take out the first card and I set it aside and then I draw a second card. So the probability of getting an ace on the first draw, since there are 4 aces out of the 52 cards, would be 4 out of 52. I don't replace that card, so now on the second draw there's only going to be 51 available cards. Also, if the first card was an ace, that means there's only 3 left in the deck. So 4 out of 52 times 3 out of 51 is 12 over, and 52 times 51 is equal to 2652. So start reducing that down. First, I'm just going to divide them each by 2, and that would give me 6 over 1326. I can reduce them both by 2 again, and that would give me, that would give me 3 over 663. And 3 will go into both of those, 1 out of 221. And changing that to a percentage, that gives me 0.0045, so it would be 0.45%. Okay, so not 45%, but 0.45. So pretty slim chance that you're going to get 2 aces in a row. Just randomly drawing from the deck. Okay. What is the probability of drawing an ace followed by a king and then a queen, this time with replacement? So each time I'm going to have the 52 cards in the deck. So the probability of drawing an ace on the first draw, since there are four aces in the 52 cards, would be 4 out of 52, times the probability of getting a king next, and there are 4 kings. And again, because we replaced the card, there's still 52. And then a queen would be 4 out of 52. So 4 times 4 times 4 is equal to 64. 52 times 52 times 52 is equal to 140,608. So go ahead and reduce this. I'm just going to keep dividing, let's see, 32. I'm just going to hurry and reduce this. Reduces to 1 over 2197. So you can see why winning at card games is very low percentage of success. Okay, so 1 divided by 2197. Now in my calculator, it's coming out like this. 4.55, and then it has a bunch of other decimal places, and then it says e to the -4th. Okay, that means it's in scientific notation. That to the -4th means that this decimal goes 4 places this way, which means it's actually 0.000455, and that's the decimal. So to change that to the percentage, I would move this decimal back 2 places to be 0.045%. So you have less than 1% of chance of getting an ace and then a king and then a queen. All right, so let's see if there's any others we wanted to go over. Okay, so there are these little things called probability trees, and the way that this works is that there are more than one branch. So the first choice may be like if you're making a sandwich, you have 2 choices for bread. One choice is wheat and one choice is white. And maybe like a restaurant is going to I guess, track how many people choose wheat and how many people choose white. So it looks to me like they've decided that 45% of people choose wheat and 55% of people choose white. Of the people who choose white, 23% of them choose ham and 77% choose turkey. Of those who choose wheat, 65% choose turkey and 35% choose ham. So that's what this table is telling us. It could have more branches on it, like once if they chose both wheat and ham, there may be a choice of whether they chose Miracle Whip or mayonnaise on their sandwich. So it can continue on. But it's a kind of an easy way to organize information. And then we can use this to use the multiplication rule to find out different probabilities. So let's go ahead and look at some different questions. So what is the probability of ordering a sandwich on wheat bread? That one is pretty straightforward. It's just right there, right? It would just be 45%. 45% of people are choosing wheat. What's the probability of ordering white with turkey? So because they're ordering white, I'm going to be looking at this part of the table right here. Okay, so the probability that they just chose white in the first place is 0.55%. Well, we're going to multiply that by the chance that they both chose turkey and then chose white and then chose turkey. So 55% chose white. Of those 55%, 77% chose turkey, which comes out to be 0.55 times 0.77 equals 0.4235, which comes out to 42.35%. So about 42% of people are choosing white bread with turkey. Okay, what's the probability of ordering a sandwich with turkey? So now notice on this one, we have just the turkey, right? But it occurs twice here. So if we have to go on more than one branch to find both, then we're going to add them together. So we still multiply, we still use the multiplication rule on each individual branch, but if I have to go across branches, I will add those together. So what's the probability that you ordered wheat with turkey? That would be 0.45 times 0.65. Okay, and then we're going to add that to the other branch. If I chose white, 0.55, and then turkey would be 0.77. So we use the multiplication rule as we go out on the branches. If we go across branches, then we add them together. Okay, so 0.45 times 0.65 is, 0.45 times 0.65 is equal to 0.2925. We're going to add this to 0.55 times 0.77, which is 0.4235. And when I add those together, it gives me 0.716, okay, or 71.6% of people are getting turkey. Okay, let's try another one of those. What's the probability of ordering a sugar cone? So the sugar cone was just right here, 52%. What's the probability of ordering a chocolate cake cone? So we're going to be looking at this branch, okay, chocolate and cake cones. We're going to multiply 0.48 times 0.66, which is equal to 0.66, which is equal to 0.3168. So 31.7% of people are choosing chocolate cake cones. And then what's the probability of ordering a vanilla ice cream cone? Okay, so again, vanilla is on both of these. So we need to go out on both branches. So sugar cone and vanilla would be 0.52 times 0.54. And then we're going to add that to the other branch, which would be cake cone at 0.48 times vanilla at 0.34. Okay, go ahead and simplify that. That would be 0.48 times, okay, that would give me 0.444, or 44.4% of people. Okay, so that's pretty much it for today. Please let me know if you have questions, and I hope you guys have a great day.